Okay, grade 11s, welcome back to processes along our nephron that we are discussing today. So I've already done a video basically talking about how we have glomerular filtration, we have reabsorption of all of our useful substances, fatty acids, amino acids, glucose, vitamins and minerals, we reabsorb it. I've just done a video for salt, the regulation of salt under the influence of a hormone called aldosterone. And now I'm going to actually look at the second last process that happens along this nephron, which is regulation of pH. Okay? Regulation of pH. Right, so in order to do pH, we actually have to have an understanding of pH first. So pH stands for percentage hydrogen. Percentage hydrogen. The more hydrogen there is present, hydrogen ions that are dissociated from a specific in a solution, the greater the acidity. The greater the acidity. Okay. So if you have more hydrogen, you basically more hydrogen ions that dissociate in a solution, that will cause a solution to be acid. That will cause a substance to be acid. Now pH is regulated on a scale from 1 to 14, 7 being neutral, 14. This is our most acid kind of content. 7 represents neutral and 14 is alkaline or base or bases. Okay? So that's a basic pH scale. What this means, grade 11s, is that if you have something that is very, very acidic, it's got a lot of hydrogen ions. Hydrogen ions. Okay? Hydrogen is used to, when there are hydrogen ions, there's a lot of acidity. Okay, so it's hydrogen ions make it acidic, while bicarbonate ions, HCO3 minus, which is bicarbonate ions, make the blood more alkaline. Okay? So when we're regulating pH, of the blood, we are going to regulate hydrogen ions and we're going to regulate bicarbonate ions. Okay, so the pH of blood, what is blood normally? Blood is usually about a 7.2 to a 7.4 pH. Okay? So slightly alkaline. But yeah, so we're on the alkaline scale. What's going to happen if we change the pH of the blood and we make it more acidic? Okay, so let's say we push it, okay, to 6.9 pH, slightly more acidic. We can't have that happening. We need to regulate that pH. And so we need to balance it back to push it onto where it should be in terms of pH. This is called regulation of pH. Now, the regulation of pH happens at a specific area of the nephron. That is the next part. And so I'm going to draw it over here. I'm going to start with the loop of Henle. So we just have our loop of Henle that we've just come out of, and that was the regulation of salt. So salt got regulated over here, and we're now in this area called the distal convoluted tubule. Map joined to the collecting duct. So I'm just going to write here distal convoluted tubule. And remember that blood vessel that we were talking about before, that efferent arteriole, that arteriole loops around here, all over here. Okay? That's why I didn't want to draw it on before, because it does make it quite complicated to see what on earth is going on here. Okay? So there's our blood. So blood inside of this blood vessel. Okay? If the blood is too acidic, that's what we're talking about. Okay, so we've shifted the pH so that we have a lot of hydrogen ions in here. That's basically what this means. It's very, very acidic. What we want to do is we want to excrete the hydrogen. In other words, we want to force the hydrogen out of the blood. So let's say we have H plus over here. We force it out of the blood into the tubules. Because remember, once it's in these tubules, you can see see where it's going. It's going to be lost in the urine. It's going to be excreted, eliminated. So we want to excrete the hydrogen ions from the blood and we eliminate it in the urine. So if the blood is too acidic, we are going to excrete hydrogen ions. That's not the only thing we can do. So remember when I said we can regulate, if we want to push something a little bit more alkaline, we need more bicarbonate ions. So we excreted hydrogen ions, we said get out hydrogen ions, we don't want you, we've excreted it from the blood into the tubule. We can also reabsorb, in other words, take back, reabsorb bicarbonate ions. Because in here, we have some bicarbonate ions that got filtered right at the beginning. HCO3, HCO3 minus. There he is, okay? We can reabsorb that to basically try to make the blood more alkaline, to push it onto the alkaline side. And so we excrete hydrogen, but we reabsorb HCO3 minus until, so that's going to push us back onto the scale until we reach what we refer homeostasis. We get into our normal pH. Normal. We want to get to pH 3 normal. Okay, so when our blood is very acidic, we excrete hydrogen ions from the blood into the tubules to be lost. We're going to get rid of them in the urine. Okay, and we reabsorb bicarbonate ions so that we can push it more alkaline. Okay, so grade 11, it's going to work in the exact opposite way if your blood becomes too alkaline, because your blood can become more alkaline. So normal pH here, if you now push your alkalinity this way and your blood becomes too alkaline, let's say it goes to like a 7.9 or whatever, okay, it's now too basic, the blood has become alkaline, what can you do? Okay, the exact opposite to what we just did. So now if our blood is alkaline, we want to reabsorb hydrogen. So we're going to take hydrogen back now, and we're going to excrete bicarbonate. So it's the exact opposite. So we are going to excrete, let me just get a pen maybe that can help me with this, green maybe. We can excrete, what do we want to do? Bicarbonate ions, HCO3 minus, and we can reabsorb hydrogen ions. In other words, to push our pH back till normal. So we're making it more acidic, or we're absorbing more hydrogen ions to push us back into this normal pH range. And grade 11, that's how we regulate pH. It's possibly a little bit more complicated than some of the other things we've done so far, but yeah. Okay guys, the next one we're going to be doing is water, and I will do that video in a later stage. So those are the three things I wanted to cover today. Was filtration, 4 things actually. Filtration, reabsorption, salt regulation, and pH regulation. And that's it for today. Thanks grade 11s. Have a wonderful week, and I will keep uploading videos. I hope you guys are working from home. Cool guys. Cheers.